we are going to use a data model for the purpose of data abstraction. So that has to show only the essential feature by suppressing or by hiding a background details. Each object, whatever we have in a schema or a description of a database, then we call that as what? Schema construct. When it comes to the conceptual data model, there we can expect more abstraction. Abstraction level is high in the conceptual data model. Hello everybody, a warm welcome to one and all. Welcome back to the session 2 of chapter 1 in the unit 1 of B.Ca's third semester, subject called Database Management System. In short, it is DBMS. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Before getting into our today's session, we'll just have a quick recap of our previous session. As you all know that in the last session of this chapter, we had a discussion regarding introduction part about this database. So we got to know what do you mean by data, what is an information, and also we had a discussion regarding introduction regarding this database as well as database management system, and also we had a discussion regarding this applications of database, and also you got to know what are the characteristics and what is the purpose we have behind this database approach, and also we got to know who are all the people associated with the database system, that is actors on the screen, actors behind the screen, or you can say workers of this database system. There we have a DBA or database administrator, system analyst, and also we have a programmer, application programmer, designer, and also we have a end user. Those are the things which we had a discussion in the last session. So in our today's session, we're going to see what do you mean by data models. Why do we require it? Along with that, you will get to know what is database schema, and then I will be discussing regarding the database architecture. At last, you will get to know what is data independence. We'll see each topic one by one. Let me start with the data models here. So if you consider the database approach or a database management system, moreover we are going to use that for the purpose of abstraction. You already know that how to use WhatsApp, how to use washing machine, how to use any of the electronic gadgets. But do we really know how it is working internally? No, right? Why? Because it's of abstraction. So that is giving only the essential features by hiding the background details. We won't get to know how it is working, how it is developed in a background. But we all know how to use, how to get a benefit from that. Then we call that kind of process or that scenario as what? Data abstraction. So that we can expect this database approach that will going to provide a data abstraction. So in order to get the data abstraction, we are going to use this data models. Then why do we require this data model? What it means? You can see here. So data model is a collection of concepts that can be used to describe the structure of a database. So we are using a database models, or we are using this model in order to describe the structure of a database. So in that structure, it will going to include all the necessary means in order to achieve this abstraction. So abstraction is necessary for database. So by making use of which concept we can enhance the abstraction, then we call that collection of concepts as what? Data model. So it is a collection of concepts which will going to be used in order to describe the structure of a database. How the database should be, what are the constraints, what is its data type. Everything we are going to specify in this structure of a database. So and it has to follow or it has to include the abstraction. For that reason, we have this data model. Then here you can see that. So by the structure of a database, if I say the structure of a database that comprises of relationship, constraint which we are going to apply to the data. It also going to include data type. What must be the type of a data, whether it needs to be varchar, integer, or it needs to be date data type. So we should specify the data type and relationship. That means the associativity between the different entity, and constraint. What are a set of rules and regulations that we are incorporating on the data. So everything will going to be specified under this structure of database. And here you can see that most of the data models include a set of basic operation in order to specify the retrievals and updates on the database. Along with the structure of database, this is also going to specify the retrievals and updates commands over this database. So by making use of this data model, we can specify the structure of a database. So now you can see the categories of data models here. So how do we categorize the data models then? Already you know what is data model. So here we are going to categorize the data model according to the types of concept. As I told earlier, this data model itself is a collection of concept. On what basis or what kind of concept it is, that is type of a concept, then we are going to use to describe the database structure. In order to describe the database structure, what concept we are using. Based on that category, we are going to divide or categorize this data model into three types. One is high level or conceptual data model. We have a representational or implementational data model, and then we have a physical data model or low level. High level, intermediate is this representational or implementation, and we have a low level data models. We'll see each type one by one right now. First, what we have here, high level or a conceptual data model. As I told earlier, we are going to use a data model for the purpose of data abstraction. So that has to show only the essential feature by suppressing or by hiding a background details. When it comes to the conceptual data model, there we can expect more abstraction. Abstraction level is high in the conceptual data model. So here, this will going to use, or this conceptual level will going to use the concepts such as entities, attributes and relationship. How it will going to describe the structure of a database? By including the entities, attributes and relationships. Then what do you mean by an entity? An entity can be any real word. Can I call this as an entity? Can I call this as an entity? Yes, we can call any real world object as an entity. Then that is what that specifies the real world object or concept. If you consider the employee, he is also an entity. If you consider the department, that is also an entity. Then what about this attribute? Attributes specify the features. If I wanted to say someone as employee, how can I get to know? They must have an employee ID, employee name, they should draw a salary. That is what we are calling those features as what? Attributes. This attribute will going to represents the properties of an interest that further describes an entity. If I wanted to call this as a digital pen, then it must have certain features. It must have a color, it should be used for writing, it should have an ability to sense. That's what? That is what we are calling that as a attribute. Then what about this relationship? Relationships are nothing but an association among the entity. How this entity is related with this entity. Then we are finding a association between those two entities. Then we call that as what? Relationship. So that this conceptual or high level data model will going to use entity, attributes and relational concepts in order to describe the structure of database. Fine. Next, what is the second type? Second, we have a representational or implementational data model. Then how it is used or what kind of concept it is going to use? It will uses the relational database representational data model in order to represent the data by using record structure. So it will going to have a table. In the table it has a columns as well as rows. We are calling that rows as a tuple or a record. So you can see here this relational database. If I say RDBMS or a relational database, that always going to deals with a table. If it is a table, then that should comprises of a column and that should must include this rows. Then we are calling this rows as a record or a tuples. Whenever we are using this kind of concept in order to describe the structure of a database, then we call that as a representational or implementational database. So here, whenever we are representing the data by making use of this record structure, that's why we are also call this as a record based data models, and also it will going to include data models like network and hierarchical models. So that is also used in order to describe the structure of a database. We'll see the last one, that's physical data model or low level data model. So when it comes to the low level, where the actual data got stored in a database, in order to represent it, we are going to use as a file. So it describes how the data is stored as files in the computer by representing the information. So how can I get to know, or what concept we are using? We are using a file data structure here in order to represent the structure of a database, and that information regarding this file include record format, what is its format, along with that it includes record ordering, how the order of that files, and then access path, how can I access that. Access path will going to specify a structure that makes the search for particular database record in an efficient manner. So if I know what is the index, or if we know where it is in a particular location of a database, then it will be easy in order to access it. For that reason we require this access path. Fine. So by making use of these concepts, we are going to describe the data structure. By using these concepts, we are going to define the structure of a database. So these are the data model. We have a conceptual, in the conceptual entity, attribute and relationship, and we have a representational. We are representing the structure of a database by making use of RDBMS, and we have a low level. Here we are describing it with the help of file. In that file, that includes record format, record ordering, as well as the access path. I hope you all understood regarding this data model. Let me move to the next concept. That's all regarding what? Schemas. So what do you mean by schema here? The description of a database is called the database schema. Whenever we are describing a database, how it is, what it is, why do we use it. So whenever we are describing that database, then we call that as a database schema. So mainly which is specified during the database design, and most of the time we should not frequently change the database schema. It's like what? Construction of a college. So for every year students may come and go, but the infrastructure should be same. It should not be get altered frequently. Then we call that as what? This schemas are a database schema. So the students are coming and going, then we call that as a database state. So database state may change frequently, but it should not change the schema in a frequent manner. So that the data models have certain convention for displaying the schemas as a diagram. So here, whenever we are having a description of a database, we can also describe that in the terms of diagram. Then we call that diagrammatic representation or a displayed schema as a schema diagram. So we are going to represent that in a diagrammatic representation. Then we call that as a schema diagram here. This schema diagram consists of what? It will showcase us record types, as well as it shows what is the data item, and also some of the constraint or set of rules and regulation whatever we have in a database, that is also going to be displayed in this schema diagram. And whatever the object, each object whatever we have in a schema or a description of a database, then we call that as what? Schema construct. So all these whatever the bolded words I have here, all are important question. Define database schema, schema diagram and schema construct. Fine. We'll move to the next slide. Here what we have, the actual data in the database may change quite frequently. As I told earlier, if I consider a college as a schema, that should not get frequently altered. But the students, whoever coming in and going out, may change frequently. Fine. So the data in the database at a particular moment in time is called as a database state or snapshot. Very, very important content here. What is schema and what is database state. What is database schema? Database state. So database schema represents the description of a database, and database state represents the data in a database at a particular moment. So if I have a 200 students in a college at this moment, then I can call this as a database state. So after 5 minutes or 10 minutes, some students may add on or some students may leave the college. So at the time, if I am counting the number of students, what is the number of students present at that particular time, then we call that as another database state or snapshot. Okay, schema should not get frequently changed, but we can have a change in the database state or a snapshot, so that the data in the database at a particular moment in a data, then we call that as what? Database state or a snapshot. And also we can call this as a current set of occurrences or instances in the database. We have a alternative name: database state, snapshot, occurrences or instances in the database. Then the DBMS is partially responsible for ensuring that every state of the database should be valid state. Whatever could be the content or whatever could be the values, that state or its particular moment, whatever we have, everything should be valid data. So if it is a valid data, then only we can expect consistency in the database. So here you can see that the DBMS will going to store the description of the schema construct as well as the constraint. Then we call that as a metadata. Metadata is what? Data about data. Database itself or DBMS itself a data, that is storing a description of schema construct as well as the certain construct. Then we call that as a metadata. The schema is considered as what? Intention, and database state is considered as extension of a schema. So intention need not to be changed frequently, but we can have a change in the extension frequently. This is regarding what is schema, what is schema construct, and what is database state or snapshot, occurrences or instances, and metadata along with intention and extension. Fine. We'll see the next one, that is regarding 3 schema architecture. You got to know what is schema, and here we have a 3 schema architecture. How do we represent or how do we give the description of a database, on what level? That what you can see here. Already you know that the concepts or characteristics of the database. What are those? That is self-describing nature and also installation of programs data. So there must be what? Program independence and data independence, and also it going to support multiple user views and multi-tenant in nature. And also you can have a catalog here. That catalog will going to store the database description, that is what schema, and also it has a metadata, self-describing nature. So all these are what? Characteristics of a database approach. So in order to satisfy all those things, here we have a 3 schema architecture. In order to satisfy the characteristics of a database approach, we have this 3 schema architecture. So that an architecture for the database system called the 3 schema architecture, it was provided in order to help or to achieve the visualize the characteristics. Whatever the characteristics we have all here, in order to achieve this, we have this 3 schema architecture. The main goal of this 3 schema architecture is to what? Separate the user application from the physical database. So we have certain data here. So data are stored in a database, and being an end user, there should not be any communication between the actual data and end user. If you wanted to establish a data abstraction, then there must be what? Several levels, or we should ensure the data should be separate from the user application to the physical database. In order to do this, we have this 3 schema architecture. Moreover, in this architecture, schemas can be defined at the following 3 levels, and we are defining the description of database, or we have a schema in different 3 levels. First level include internal level, conceptual level, and we have a external or view level. We'll see each level here. So here, First you can see the internal level has an internal schema. So if it is an internal level, then that is associated with internal schema. What this comprises of or what it describes? It describes the physical storage structure of the database where the actual data is getting stored, that is in the physical level, which will be at the bottom. So this schema represents the physical storage structure of the database. How many files we have, what are the record type, what is record ordering, every data will going to be stored in this internal schema, and it uses a physical data model. What kind of model it is using? Physical data model. Already you know what is low level or a physical data model. This uses that model, and also it going to describe the complete details of a data storage and access path. How can I access the file of a database? How can we reach to that location in order to retrieve the content? So all those information will going to be stored in this internal level or internal schema. What is the higher level than this internal schema? There we have a conceptual level. If it is a conceptual level, then we are going to use the conceptual schema here. And mainly this describes the structure of a whole database for a community of user. This will going to shows what is the structure of a database for the user. That user may be database administrator, analyst, end user, or even for the designer. So that this conceptual schema hides the details of physical storage structure and concentrate on describing the entities, data types, and relationship and user operation along with a constraint. Already you know about the conceptual schema. So in that level, it has entity, attribute, relationship, and also it shows some of the operation and set of constraint. So by including all these, by concentrating on all these, this will going to hide the details of physical storage structure from the user. So you just imagine here we have a user, and user wanted to access the content. This is physical level or this is low level schema. In between here we have this conceptual schema. So this conceptual schema will going to hide the content from the user who cannot access this actual data. Okay, so this conceptual schema or a conceptual level will going to focuses on what is the entity, what are the relationship, attributes, and user operation and constraint. Fine. And here the representational data model is used. So we are going to use a representational or implementational data model, that is our DBMS we are going to use in order to describe the conceptual schema when a database system is implemented. And also here it is moreover based on the conceptual schema design in a high level data model. This is what will going to happen in a conceptual level. Then whatever we have in upper level, then we call that as a external or a view level. So where the users are sitting and getting a benefit, then we call that as what? External level. Mainly it will going to include number of external schemas or user views. So user views will going to be there in this view level or external level, and also it is going to use the external schema. Then each external schema describes the part of a database that a particular user group is interested in and hides the rest of the database from that user group. So with this external level or a view level, we can expect more abstraction. So we won't get to know where we have actual data, how it is getting processed, and how it is transmitting from the lower level to upper level. That and all we don't know. We just know how to access the content. That is what we can expect more abstraction in the external level. So here each external schema is typically implemented using a representational data model and based on the external schema design in a high level data model. So then by making use of representational data model, it all going to get developed and it will make it reach to the user as a resultant. Here you can see its diagram. So now you can clearly understand what tree schema architecture is all about. As I told earlier, it has three levels. One is internal level, and we have a conceptual level, we have a external level. You all need to understand one thing. In the internal level, it will going to use internal schema, correct? And it has a physical storage database where the actual content of a database is storing here. And being and sitting at this external level, end user want to access it. How can they access? So whatever the command or whatever the request that I am sending can't be understood by this physical level. And whatever the written value, if it is going to send to the end user, that can't be understood by the end user. Then we should have a mapping. That means if I am sending some of the requests to the low level or to the internal schema, then this conceptual schema should help us in order to send the request from external view to the internal schema. So then it can understand, it can process the content, again it can send the result in the terms where external user or end user can understand. This is how we are doing with computer, that's all. So we know English, computer know only binary language. So we are going to send a command in English and we have a language translator. That language translator will going to translate it into binary language. Then computer understands that. Then processing has been done. Again it will going to send the result in the human understandable form. So in order to do that, we require a mapping here. So for that you can see here conceptual or internal mapping. So the mapping or exchanging of data is taking between this conceptual as well as internal schema. So when it got exchanged, you can see these all are bidirectional. We are having an exchange of data from one level to another level. Again we should have a mapping between the conceptual as well as to the external level, that we can see in between this external level as well as in the conceptual level. Fine. Actual data we have, I wanted to access it. The end user needs to access the content. By making use of this conceptual schema, that interpretation of the request will going to be done, and again it will reach to the internal schema. It will fetch the content. Again it move back to the conceptual schema. It reaches to the external view. There we have abstraction. The end user can see whatever they are requiring for, but they won't get to know how the data actually stored. This is how 3 schema architecture works. Very, very important question that you can expect in your examination as well. Fine. By understanding this, we'll see what are the types of DBMS architecture we have. Here you can see that the DBMS architecture, moreover the DBMS design will going to be depends on the architecture. What kind of architecture we are using. Based on that, the design of a database will going to be specified. So that the basic client server architecture is used to deal with a large number of PCs, web servers, database servers as well as other components that are connected with network. Here we are using client server architecture. So if we say client server architecture is what? Client means browser. So we have to send some request to the server. Server will going to interpret our request, then it will fetch the content from different servers and it will return the response back to the client. That is what happening in a client server architecture. Main intention is what? It has to satisfy the requirement of a user by sending a response. Client has to send a request, server has to send a response back to the client. So that in this client server architecture consists of many pieces, many computer or personal computers will be there, and also it will going to have a workstation, computer with internet connection, then we call that as a workstation, which are connected via network. So with the help of this, we have a 3 types of architecture here. So that includes 1-tier architecture, 2-tier architecture and 3-tier architecture. We'll see what each tier will going to do now. We'll see the first one, that is 1-tier architecture. As the name indicates, 1 tier. There is no any other interface between the client as well as a server. So in this architecture, the database is directly available to the user. Very important. So I can have a direct access to the content of this database if we are following this 1-tier architecture, so that the user can directly sit on the DBMS and uses it. Whatever the changes that we are making in a database directly will going to be done on the database itself. And also, it does not provide any handy tool for the end user. In between, we don't have any other tools in order to use the DBMS. Directly, we are working with the DBMS content. If we are doing any changes, that will directly affect on the DBMS itself. Then we call this kind of architecture is what? One-tier architecture. And also, next what we have? Two-tier architecture. Somehow it is, if it is two-tier, it's like a client-server architecture itself. So, here client-server in the two-tier architecture, applications on the client end can directly communicate with a database at the server side. For this interaction, we require a APIs, Application Programming Interface, that is ODBC and JDBC. So, these are the two APIs which we are going to use in order to have a communication between the client as well as to the server. So, we are the client and I am seeking for some response from the server. So, by making use of this interface ODBC in between the client and server, we are sending a request and server is sending a response back to the client, so that the user interfaces and application programs are run on the client side. So, with the help of this interface and application program, we can send a request to the server. In the server side, responsible to provide the functionality like query processing and transaction management. That will going to be done by the server side. After that, to communicate with the DBMS, client side application establishes a connection with the server side. How it will look like? You can see here, we have a client, we have a server. So, with the help of this application programs, client will going to send a request to the server. So, in the server, we have a database system. Server will going to fetch the content, or it is going to helpful for us in order to make a transaction management as well as query processing. That will going to be done here, and again it will send the response back to the client. This is what? Two-tier. So, we have a clear separation between the client as well as server. In between, we are going to use a ODBC, JDBC API in order to communicate with it in the application. Fine. Next, what about this three-tier architecture? It contains another layer between the client and server. We have a client, we have a server. So, we have one more layer between that client and server. Then we have a total 3 layers here. So, in this architecture, client cannot directly communicate with the server. In the previous slide, we got to know regarding two-tier architecture. So, in that, user can directly communicate with the server. Fine. That means we have a client, we have a server. With the help of APIs and application, we can have a connection to the server. But that can't be happen with this three-tier architecture. We have more security here. Confidentiality of data will going to be improved by having more abstraction, so that the application on the client end interacts with an application server, which is further communicates with the database system. Understand? Here we have a client. Client will going to be communicated with the application server, and this application server will going to communicate to the database. Okay. So, client, we have client in the lower end will going to communicate to the application server, and that application server will going to communicate to the database management system. Client directly cannot communicate to the database here, so that end user has no idea about the existence of the database beyond the application server. They are just cheating us by hiding all these information. That is what data abstraction is here. So, we don't know what we have or what we have behind that application server. We can't access that content. So, it is improving the efficiency and abstraction also. The database also has no idea about another user beyond the application, vice versa, so that it can be used in the large web application. So, here you can see that how the client server architecture of three-tiered architecture look like. So, here we have a user and application client. Application client will going to send the request to the application server. Application server will going to make it reach out to database. Then same thing will going to happen in a reverse order in order to send the response. These are the different types of DBMS architecture. I hope you all understood regarding this concept also. Let me move to this data independence. Very important. What is data independence here? Here you can see that the 3 schema architecture can be used in order to define this data Independence, already you know 3-scheme architecture. We have more abstraction here. We have a low level, conceptual level and external level, correct? By making use of that 3-scheme architecture, we are explaining this data independence. Then what is this data independence is all about? You can see here the capacity to change the schema. So we are changing a schema. That means the description of a database, that we are making a change at one level of a database system without having to change the schema at the next higher level. We have a low level, conceptual level, external level. If I wanted to change the low level content, then that should not affect the conceptual level. If you are doing a changes in the conceptual level, that should not affect on the external level. So if you are making any renovation in the ground floor, that should not affect on first floor. If you are doing any changes in the first floor, that should not affect on the second floor. That is what we are having in this data independence. By making use of 3-tier architecture or by making use of 3-scheme architecture, we can have this data independence. What is data independence? Categories of data independence, a very important question that you can expect. So, it's a capacity to change the schema at one level without making any changes or without having to change anything to the next higher level schema. So, in order to define this, we have 2 types of data independence that include logical data independence and physical data independence. Physical data independence deals with a physical level or low level, and this logical data independence deals with a conceptual level or mid level. You can see here we have a logical data independence. It is a capacity to change the conceptual schema without having to change the external schemas or application program. Understand? Here we have a low level, conceptual level, external level. I am changing the conceptual schema without any change to the external schema. Then we call that as a logical data independence. We can't do any changes in the external level. Already that is at the utmost level. Upper level or high level don't we have. So that we can make only the changes in a physical level or in the conceptual level. So we can change the conceptual schema to expand the database. I can expand the database, or we can improve the records, or we can improve the entities, attributes like that, and adding a record type or data item, and also we can change the constraint. We can change the set of rules and regulation, and also we can remove certain record type or data item by having a updation or reduction in the database. So all these we can make without changing the external level or external schema. The best example is what? Updation of any of the application. So we are all using any social medias as well as WhatsApp. So until we are going to get a message like update, we don't know what they are doing in a background, correct? So they were working on the behind in order to improve the efficiency, but we all don't know what is happening beyond the database or beyond this application. Same way, that is not affecting in order to use the WhatsApp or in order to use any of the social media. So we are not getting affected by this. With the help of this logical data independence, whatever the changes they are doing in a background will not going to affect on the usage or on the external level. Then we call that kind of data independence as what? Logical data independence. So here you can see that after that we have a physical data independence. So if you know the logical data independence, physical data independence is same. Physical data independence is what? It's a capacity to change the internal schema, that is low level internal schema, without having to change the conceptual schema. We are not changing any entities, attributes, record, constraint like that. I am only changing the actual data content, that is in the internal level or in the internal schema. So if it is not getting affected, or whenever we make a changes to the internal schema without affecting the conceptual schema, then we call it as a physical data independence. And here you can see that the external schemas need not to be changed as well. No need to worry about the conceptual as well as external, that needs not to be changed. So changes to the internal schema may be needed because some physical files were reorganized. So in the physical level or internal schema, we have a files and ordering of files and grouping of files is taking place. In order to do all those changes, we have this physical data independence. Fine. If the same data as before remains in the database, then we should not have to change the conceptual schema. If you are not changing a conceptual schema, then it's not going to affect anything to the external schema. So by this, we can have a physical data independence as well as logical data independence. Totally, it will going to provide some data independence. What do you think, which is more harder, whether physical data independence or a logical data independence? Somehow logical data independence is harder. Why? Because whenever we are making a changes, that should not affect on the external level. Our application program should not get affected by that. That's why we can say that logical data independence is somehow harder in order to do the changes, and with the help of this physical data independence and logical data independence, we can have a abstraction. If we have a abstraction, then there will be more consistency in the data as well as confidentiality will be there. I hope you all understood my today's session. In my coming session, we're going to see about this database languages. What are the different database language we have? Along with that, we'll see about the interfaces, how do we communicate with a database, and also we'll see the classification of DBMS. Let me meet you there. Until that, keep learning, keep on growing. Thank you.